Alright, sorry that I made this so late, but I wanted to make sure it got out there before we had the test. So, I'm just going to go over this review. I'm going to post it later. Well, I guess by the time you see it, it's already been posted. So, we're going to calculate the volume for each figure. We are most definitely going to be using 3.14 for pi for the rest of this video. And we're going to try to round our answers to 2 places, which is the hundredths place. Okay? So, as you see, we have cylinders here. Remember, the volume formula for cylinders is going to be V equals pi r squared times height. So, as you can see over here, we have 12, but that is reaching to both sides of this cylinder, meaning it's a diameter, and we need to take half that to get our radius. So our radius is going to be 6, because 12 divided by 2 is 6. Then it's just a matter of plugging everything in. So V equals pi, but we're going to use 3.14 times the radius squared, 6 squared times the height, which is 2, right here, 2. So I'm just going to go over here to my Desmos calculator. May shrink it a little bit if I can. Let's see, make sure. There we go. So 3.14 times 6 squared times 2. And we get 226.08. See, I'm going to start writing, it's going to go away. Let's see if I can't remember it. 226.08. Just for a final check to make sure I remember it correctly. Yes. Also, I told you to be careful about those units. 2 tick marks means inch. So this would be inch cubed would be your answer. Perfect. So, the cylinder to the right, again, this is already half this distance, so that should be our radius. And just because the cylinder is laying on its side, that means this 20 is going to be our height. So again, plug everything in. So our volume is pi, 3.14. Radius, 8 in the situation, squared, times the height, which is 20. Again, I'm going to pull up Desmos. Sorry, hiccup it a little bit. Hopefully I can get this done for my little electronic pin dies. There's a small battery, and I did not charge it before filming. But as always, you just plug it in like you see it the best you can. 20, and there you go. 4019.2. 4019.2. 0 since we're going to 2 decimal places. Well, let's check real quick. Yes. There you go. There's your cylinders. Let's move on. Cones. Remember the formula for cones. That's volume would equal for a cone third times the base, which these are circles. So it'd be pi r squared times that height. And again, sorry for writing. I didn't get to use my normal pen because it's dead, so I'm using a smaller one, and it's difficult to write on the screen with it. So, same as before. The 16 is the diameter, so we need half that, which means our radius is 8. 16 divided by 2 is 8. We don't want the 7, we want the 8. That would be our height. Just looking over here at this other cone, this 2 would not be what we want. We want the 7, because it makes it 90 degrees with the base. And this 6 would be our radius. So, as always, just plug in what you know. Volume is going to be 1/3 times pi, but we're using 3.14, times the radius, which is 8, squared, times that height, which is 8. A lot of 8s for this one. So again, pull up Desmos. I'm just going to move it over here. Again, I'd be using my handheld calculator, but I'm using a different computer and I don't have that software on this computer. Then again, the more I think about it, I feel like I do, but I just can't find it. But regardless, we'll just go ahead and use Desmos. It's the same as the Casios, not a big deal. 3, scroll over, times 3.14 times 8 squared times, oh, where to go? There you are. So 535.89. And again, these are in inches cubed. Whoop, put a little limb there. That's silly. Bam. And again, for the one on the right, plug in what you know. We got our volume, 1/3, times pi, which would be 3.14, times the radius squared, which is 6, times the height, which is 7. Pull up Desmos one more time. Move it out of the way for you. And again, back. We can keep all that, and that's going to stay the same. So we'll start here. Radius 6 squared times 7. 263.76. 263.76. Easy peasy. Well, especially if I can remember to put the units. There we go. Alright, cones are out of the way. Let's see what's next. Spheres. Again, don't be fooled. That is the diameter, so we want the radius. So, radius is 6. Formula for a sphere is going to be 4/3 pi r cubed. So, plug in what you know. Volume 4/3 times the pi, which I told you we're going to use 3.14 for this whole worksheet or review sheet. Radius is 6, and we're going to cube it. And again, pull up your calculator. I'm going to clear all this and go straight to 4 divided by 3 times pi, which is 3.14 again, times the 6 raised to the 3rd. 904.32. 904.32 is going to be the volume for this sphere. Again, it is inches cubed. This guy is simply just going to be 4. So I'm just going to scroll down, give me some space. The volume is 4/3 times 3.14 times 4 to the cubed, or 4 to the 3rd power. Again, I'm going to pull up Desmos, but remember, work smarter, not harder. I'm just going to simply change that 6 to the 4, because everything else should be the same. So this one is 267 point. That 6 rounds that 4 up to a 5, so 95. So 267.90. Oh my goodness, I think I've already forgotten what that number was. Let me pull it back up. Indeed, 95. So 267.95, because again, that 6 rounds that 4 up. And it is inches cubed. Alright, let's see what's next. I think it's going to be pyramids, and indeed I am correct. Remember, all these volumes share the same kind of formula. These cones and pyramids. It's always 1/3 times big B H. And remember, the big B changes. So cones had circles. These pyramids are going to have rectangular bases. So we're going to change that for length times width. Multiply by that height, and we're going to get the formula for these square, rectangle-ish pyramids. So, feeling what? Oh, we need the whole distance over here. I'm going to go ahead and tell you this guy is in the middle. It may not look like it, but it is. So this 6 is going to carry on over here to give us the whole base, which is going to be 12. 6 plus 6 is 12, and then we have the 2 there, so there's our length, our width, fact, I'll go ahead and write it right here. Length and our width. 10 is what we're going to want to use for our height. Not the 13. It's a lateral surface edge. So we have everything we need. We just got to plug it in. So volume for this pyramid will be 1/3 times length 12 times width 2 times 10 for her height. Again, we're going to pull up Desmos and move it over here to the side so we can see what we're typing in. I'm going to clear all this for us. And we're going to go 1 divided by, whoops, that's a question mark. There we go. 1/3 times 12 times 2 times 10. And indeed, we get 80. So, AT is the volume for this one. Looking over here, I'm just going to leave the screen where it's at, but you can see here's our length, here's our width, and that 15 is representing our height. I know it doesn't look like it, but it is. It was hard to put that 15 in there. Also, if you notice, we went from 2 tick marks to 1 tick mark, so these guys are in feet. So let's not forget that when we do our units, as I forgot to do the units down here for this first pyramid. So, again, plug in what you know is going to be 1/3 times the length, we're going to say it's 4, times the width, which is going to be 4 again. This is a square base after all, times the 15. Again, pull up Desmos. Let's get it out of the way a little bit. I'm going to simply change all these numbers. I'll keep the 1/3 there and go 4 times 15, and we get, whoa, what a coinkydink, an 80 again. It's like I did it on purpose. But this is going to be feet cubed, so not inches. Alright, pause the video as you see fit, but if not, let's keep continuing. Cavalieri's principle. According to Cavalieri's principle, if slices through a 3D figures at the same height have the same... what was that? That's right, area. Or cross-sectional area, if you want to be precise or even more further detailed. Then the 3D figures have the same volume. Okay, meaning if this guy happened to be 3 centimeters cubic, and this guy happened to be, write my 3 backwards, 3 centimeters cubic, and they're both 3 centimeters high. There we go, that's better. There we go, not cubic, I was giving y'all answers. These are supposed to be areas. So, I guess in hindsight, if this area is matching this area at the same height, then both of these objects should have the same volume. There we go, in a nutshell. Let me erase. Yeah, I don't need to erase. Let's just keep moving forward. We got some other stuff to worry about. These are those composite shapes. Okay, we're going to try to get crafty with these. So, we need to first decide what we're looking at. We seem to have a hemisphere on top and a cylinder on the base. So we need 2 formulas. The volume for a sphere, which was 4/3 pi r cubed, but since it's a hemisphere, we're going to wind up dividing all that by 2. Okay. Also, since this is the diameter, that radius is going to be, again, 6. And naturally, 13 will be our height. And we're also going to use that 6 for our cylinder. You know, our cylinder's radius. Okay, and for our volume for a cylinder, remember, was pi r squared times h. Then we're simply just going to add these 2, and we'll get the whole shape. Okay, I'll go ahead and do the cylinder now. So, remember, that's the volume for the sphere, which was 4/3 pi. The radius is going to be 6 cubed. We're adding the cylinder volume. So that's going to be pi. Radius, which is 6, they're going to share it, as we were discussing earlier. Put little dots for multiplying. And that was squared, and our height is 13. Again, remember, we are using 3.14 for pi, so I'm just going to simply pull up my Desmos. Oh, you are absolutely right. I got carried away. This is a hemisphere, which means we got to divide this by 2. Let's see if we can't put all this in Desmos. It takes some doing, but I think we can do it. Let's clear all this out of the way. Let's hit the division symbol first. So, top stuff, 4/3. So I'm going to hit the fraction key one more time. We are going to put 4/3 right here. Again, Desmos can handle all of this just as much as our Casios could have. 3.14, and I'm going to times that by 6 to the 3rd power. That's our sphere, and we need to divide that by 2. I'm going to click over here to the side, and we're going to add our cylinder, which again is 3.14 times 6 squared times the 13. Again, sorry for the dishwasher. It looks like it's going through its 2nd cycle. But as you can see, we have our hemisphere to the left, cylinder on the right. Those formulas I plugged in my values. And it happens to be 1,921.68. 1,000. Oh, I've already forgotten that number. It's there, then it just goes. 21.68. 21. Uh-oh. Since my poor little computer is struggling to keep up with me. And since I had to erase it, I already forgotten the number. Don't laugh at me. 21.68. Oof. Yeah, as you can tell, it's getting a little laggy. This is inches and cubed. Boom. The cone. Let's take a gander at the cone here. Again, we know we need to take half that for our radius. And just like the cylinder and hemisphere on top, this ice cream cone, if you will, we're going to have a hemisphere on top. So, same formula we used earlier, the 4/3 pi r cubed divided by 2, since it's a hemisphere. And we're going to use this cone. Remember, the cone volume was 1/3. Okay, base is a circle, so pi r squared times the height. And again, we can just scroll down and plug all this stuff in. So, as we did earlier, hemisphere, 4/3, pi, again, we're going to use 3.14 there, times the radius, which is 5 in this situation, and this one's going to be cubed. Since it's a hemisphere, we need to take half of this. Then we're going to add that to the cone. The cone is 1/3. Pi, again, 3.14 when we type it into Desmos. Radius is going to share, so it is going to be 5 again. Squared this time, though, with a height of 10. As you can see right there, 10. And again, simply pull up your calculator and or Desmos. I'm going to use Desmos here because most of my formula is already entered. See, if I go over here to the hemisphere, I simply change that 6 to a 5, and that one's already done. Then I just simply scroll over, change this 6 to a 5 for my cone, change that to a 10, but, oops, that's 11. There we go. But remember, we have to add that fraction, that 1/3. So I'm just going to click the fraction key here, put that 1/3 where it belongs. I might even add a little time symbol, may not change. There we go. Pi squared. Okay, good. So this answer seems to be 523.33. 523.33, again, inches cubed. Okay, recognize the shapes and use the appropriate volumes and add them up as you need to. Alright, let's see. What's next? A tree. Estimate the volume of the tree. The tree's trunk has a diameter of 3 feet. We better add that right down here. 3 equals the diameter, including the air, excluding the air between the leaves and branches. Hence, the leaves on top resembles a sphere. I guess they're pretty much telling us what shape to use. And the trunk could resemble a cylinder. I guess they're telling you what we should use for the base of the trunk. Cylinder and sphere. So, it's an easy task. It's just like the composite solids. So, we are simply just going to do the sphere, which is 4/3 pi, because we've seen it 1,000 times already, times the radius. This says 30. Half of 30 is 15. Cube. Add the cylinder base. Again, diameter is 3, so we have to half that. So the radius for that guy is going to be 1.5. And this is all in feet. So cylinder is pi, radius 1.5 square times the height, which is 10. Might be a goofy looking tree, but it is a tree regardless. And as always, pi will be 3.14. I'm simply going to pull up Desmos. I'm going to hit enter to make me some space. Get this over to the side just a little bit. So 4 divided by 3, scroll over. Pi, again, remember 3.14 as the directions told us, times 15 to the third power. Perfect. Plus the cylinder. 3.14 times 1.5. We got to square this per formula, and then times 10. And our answer for this tree is 14,200.65. 14,200.65 feet cubed. Yeah. Alright, let's see what's next. Density. A clay plate has a density of 2.5 grams per cubic centimeter. So 2.5 grams per cubic centimeter. Sorry, the computer is lagging again. It comes and goes, as y'all can tell. And the volume is 88 cubic centimeters. So density, volume, and this was 88 cubic centimeters. As you remember, the formula is D equals mass over volume. They want to know what the mass is. So we can simply plug in our values. 2.5 equals mass. We don't know it. I'll leave it as an M. And volume, 88. I think in class, we simply just cross multiply. I think y'all are used to it. So M times 1 is M. And then we're going to be multiplying 88 times the 2.5. Again, good old Desmos is here for the rescue. I'm going to clear that. Sorry, excuse me, I burped a little. 2.5. 220 is our answer. And this is mass, so this guy is in grams. There we go. Easy peasy. Let's see what the next one is. Oh, a small bird statue has a mass of 86 grams. That's going to be our mass, okay? And the volume of 43 cubic centimeters. Volume of 43 cubic centimeters. Okay, and what is the density? Well, just like on the last slide, it is mass, which will be our 86, over the 43 for the volume. Again, Desmos to the rescue. I'll hit enter so we have a new line. 86 divided by 43, and we get a whopping 2. 2 grams per centimeter cubic is our answer. Alright, well, that's all I have for the review. It is a short test. Please, oh please, oh please, finish your IXL, and as always, have a wonderful day.